Hello and welcome back to Oxygen Not Included. In today's episode, we're going to be covering various production methods for refined metals. Refined metals are very important because a lot of your late game buildings are built out of refined metals, and even in the early and mid game, you're probably going to want to have access to smart batteries and automation wires so that you can get an efficient coal generation system up and running. And so knowing how to obtain refined metals is fairly important in the game, particularly as you progress through and try and develop more sophisticated systems. For example, a lot of your late game transportation is locked behind refined metals, smart storage bins, heavy conductive wires and conductive wires, steam turbines, which are one of your best options for heat deletion and produce a decent amount of power on their own. A lot of your high-end decorative stuff, recreational stuff, medicinal stuff is all locked behind refined metals. Metal tiles, large power transformers, incubators, oxide refineries, high-pressure gas vents, espresso machines, virtually everything related to atmosphere use and production, virtually everything related to automation, space scanners, auto sweepers, robo miners, conveyor loaders. A lot of stuff in the game is built out of refined metals. All this stuff in here is built out of refined metals and a few other buildings to boot. So if you want to kind of progress in the game and go further in the game, eventually you're going to have to deal with the problem of how are you going to find and produce these refined metals. So let's scroll over to my little sort of debug base over here. I've got 3 duplicates. We're still on cycle 1. This all has just been done in the sandbox, obviously. The 2 buildings that are kind of the intended way of finding a lot of your refined metals or developing a refined metal industry are the rock granulator and the metal refinery. I'm going to talk about them, but I want to kind of talk about 4 other options you have for finding refined metals in the game. These are pretty good options, especially early on when setting up an industry like this would be maybe a little bit too intensive, and there are just sort of easier solutions out there. So let's talk about them for a little bit. The first sort of solution to where do I find my refined metals is simply to dig to one of the extremes of the map. Here at the bottom of the map, option number 1 is a bunch of lead. The petroleum biomes these days are filled with refined metal. Now, lead is not a particularly great refined metal. It has a very low overheat temperature. It has a low melting point, so the building will start taking damage very early on. It's not very good for piping either if you're dealing with hot systems. The thermal conductivity is not that special for a refined metal. Typically, refined metals have conductivities in the area of like 70, 100 even. Some of the best ones have conductivities all the way reaching up to 400. So this is not a particularly thermally conductive material either. Lots of disadvantages to lead, but the big advantage is if you can just get down here, it's free to dig out. It doesn't even require any sort of specialized mining skill. Anybody who has anybody who can mine, basically, anybody who is not tryptophobic can go ahead and go and dig out this lead. So it's a lot of refined metal available for the taking. It really just requires you to figure out a smart way to get down here and not expose yourself either to the germs of a spore kid or the intense heat of this biome. If you can figure out that, tons of refined metal for the taking. The other sort of option 2 for finding metal on the map is up here in space, and this kind of takes 2 forms. The first is the components that you can take from this Gravitas facility that you can deconstruct. There aren't many of them, but there are a few, and the main important one is these windows. There are 4 windows. Each of them is 400 kilograms apiece, and they're made out of steel. These are deconstructible. Most buildings here are not. If we just click on a bunch of them, we'll see deconstruct doesn't come out as an option for most of these. Drywall does. This electronic display, no. This door is made out of steel. There's 200 kilograms here, so you could deconstruct this as well. There's potentially 1,800 kilograms of steel just in these windows and this door. And steel is one of the better refined metals. It can also be used in applications that don't call for refined metals. Any metal building can be made out of steel effectively. So there are a lot of buildings that aren't made out of refined metal that want the thermal properties that steel has and the high overheat temperature that steel has. And so this is a good way to harvest some of that early steel. In addition to that, as you play, a variety of asteroids, or a variety of meteors, I should say, will rain down upon your asteroid. In particular, the iron comets deliver to you some refined metal. Boom! And we see it flying all about the place, right? Now, there's not a lot here. This is 20 kilograms of iron. This is about 5.5. This is about 10 or 9, right? There's just little bits of iron around here. this isn't a whole lot. However, it's a renewable source of this refined metal. Continuously, you're going to get bombardment by these iron meteors, and there really isn't a lot of work to do. Once you've dug your way out to the surface, duplicates can survive in a vacuum environment for a period of time, right? They need to breathe eventually, but they can run around and gather up this iron. Even being hit by one of these meteors doesn't really do that much damage to them. So it's a kind of easy way to grab yourself a lot of really easy and early iron, in addition to the steel that you can harvest from these areas over here. So digging your way to the top of the map, just like digging your way to the bottom of the map, will reward you with some refined metals. In addition to that, I didn't find any on this map, but there are metal volcanoes that spawn around the map occasionally. And if you find one of these metal volcanoes, then you'll find a renewable source of either copper, iron, or gold. These are the three metal volcanoes that I think exist in the game at the moment. And these are pretty simple things to harvest because there isn't a lot of heat output from these volcanoes at the end of the day, just because these metals don't have a lot of heat capacity. And so you just take some water or polluted water and dump it on top of these volcanoes. You'll get a lot of refined metals more or less for free. So dig to the top of the map, dig to the bottom map, or just dig around the map and find some volcanoes, and you'll get yourself access to refined metal in large quantities. In addition to that, you're probably going to be doing some other refinement type of tasks, and one of the ones that can net you some refined metal very easily is the kiln. Here I've taken a kiln, I've heated it up to just under its melting point. This is roughly where this kiln would get to after it completes 52 operations. I've built it in a vacuumed out room so that there is no thermal communication between this kiln and anything else. These tiles underneath it, right, they're at 20 degrees Celsius, they're perfectly fine. These tiles here, 20 degrees Celsius, perfectly fine. As long as you keep this room vacuumed out that the kiln is in, this kiln can just overheat and overheat and overheat until eventually it melts itself down. The best material to make these kilns out of, these sort of sacrificial kilns, is gold, because gold is what's going to require the fewest operations in order to melt. But we see on our 53rd operation, basically, if I go ahead and queue up one more bit of refined carbon here, Bubbles is going to grab some coal. They're going to deliver it to this kiln. The kiln is going to start processing it, but then it's going to get too hot and melt. Here it is heating up. Its melting point is 1063.9. And boom. There we go. So now we have some gold. 200 kilograms, which was the weight of the kiln to begin with. And we can just go ahead and grab this and build it somewhere. Now, it is very hot, so having a way to cool this down might be something that you want to do. Here, it doesn't really matter that much. If I made this tile insulated, then I wouldn't have any heat transfer at all from this gold to anything else. Here, I've basically just taken these two tiles that this rests on and surrounded them by vacuum. So that's one way to keep things from being in thermal communication with everything else. Or you could simply just take this gold and let it dump into some water somewhere. I mean, this isn't a whole lot of heat. This is only 200 kilograms of material at the end of the day. And gold doesn't have a huge specific heat capacity, 0.129, compared to, say, water, which is 4.179, right? So this bit of gold going into a big thing of water isn't going to heat up that water by that much. So you could just have these tiles be mesh tiles and let the melted gold just kind of pass right through to some sort of water reservoir underneath. You can set these things up a variety of different ways, but it is a really nice way of producing for yourself some refined metal early on, just enough to kind of get your smart battery and automation systems up and running. You don't need that much early on, and this one is unlocked fairly early. I should build a research station so I can kind of show where a lot of these research options are. The kiln, for example, is going to be right here alongside the rock granulator. Smart batteries, which are kind of what you want to get to, aren't that far off beyond here. You also want to connect your smart batteries with automation to your coal generators, and automation is just right down here. So a lot of this is on like tier 2, tier 3. You don't even really need to have supercomputers for most of this to get your early game refined metal systems up and running. And if you set up your kilns in this fashion, one, you don't need to deal with the heat output of the kiln because that's just going to be used to melt the metal down into refined metal. That's a nice thing. But also, you get yourself some early game refined metal. So pretty simple to set up. The rock granulator is also fairly simple to set up. It's basically just going to take 240 watts of power. go to the power overlay, 240 watts of power and some duplicate labor. Dupe is going to run over here and just punch this button after loading in the metals, and it's going to take things like copper ore or iron ore or gold amalgam and turn them into refined metals. Now, there is an efficiency loss with the rock granulator. Half of the ore is going to be lost as sand, and only the other half is going to be turned into refined metal. So there is a cost to relying on rock granulators that eventually you might want to deal with. But on a lot of asteroids, there's a lot of metal around the map, and you really don't care about using the rock granulator for a lot of your metal refining operations. You're kind of willing to put up with the efficiency loss because ultimately in the end game, you'll be able to run shuttles off to other asteroids and collect various metals there. The satellite, which is I think 40,000 kilometers away, is one that's going to give you a lot of copper and steel and things of that sort. So there are ways of making refined metals a renewable resource. You're not just limited to the ore that you have on the map. You should be willing early on to just accept some sort of efficiency losses and use the rock granulator to produce some of your early refined metal. Just enough to get a lot of your power systems online. You don't need to go crazy with it, but getting those early systems online, like the smart battery and the automation to connect it up, is very important. Eventually, though, you probably want to move to the metal refinery. The metal refinery is a really interesting building. It basically will take in liquid coolant through this port right here. Right, so plumbing, liquid pipe. This port right here is where the coolant comes in, and this port right here is where the coolant comes out. And every batch that you process through the metal refinery is going to take 400 kilograms of coolant and dump a bunch of heat into it, and then at the end of the batch processing is going to output it through this output pipe. Here's where things get a little bit tricky. First off, the metal refinery takes 1,200 watts of power, which is a pretty good amount. This is 2 coal generators, and more importantly, it's going to take 1,200 watts, which is more than what a standard wire is able to support. A wire has a max power of 1,000 watts. So you're going to want to use either heavy watt wire or conductive wire. Conductive wire itself uses refined metals, so that's kind of a tricky thing to connect up the system. So you're going to need some decent amount of power to run this thing. You're also going to need to be using wires that are appropriate for this level of power. So something important to keep in mind. But also, the reason why the metal refinery is so complicated a lot of times is because there's a pretty good amount of heat that is dumped into this coolant. It depends on the metal and that metal's thermal capacity and its melting point. But basically, the metal refinery is going to output 16 kilodTUs of heat just to its surroundings, but into the coolant itself, it is also going to dump 80% of the heat necessary to raise the metal ore that you put into it up to the melting point of that metal ore. And so each of the metals that you can process through the metal refinery is going to create a different heat quantity dumped into that coolant, right? So for gold amalgam is sort of the easiest to do. And it's part of the same reason why we used gold for this kiln idea over here. Gold amalgam will produce about 10.5 million DTUs per operation. Wolframite, which you can refine into tungsten, will produce about 31 million DTUs. Copper is about 32 million DTUs. Iron is about 53.7 million DTUs. And then steel, which is one of the best of the refined metals, is going to take 93.5 million DTUs to do an operation. Again, it's 400 kilograms of coolant that this heat gets dumped into, and this operation takes 40 seconds to complete, which is roughly the amount that you'll be able to pump into this, right? A pipe is limited to 10 kilograms per second, so 40 seconds, the pipe will basically have enough time to refuel this metal refinery right before the next batch gets processed. The metal refinery itself has a 1,200 kilogram sort of internal storage, so you can have 3 batches worth of coolant waiting in the metal refinery. But yeah, this is a lot of heat at the end of the day, and you need some sort of heat solution if you want to run these things in the long term. If you just have some pool of water, that'll work for a while, right? You can take some pool of water that you have, right, like right here, and you can have a pump pumping it in, and then you can just have it outletting right back into this spot. But eventually this water will heat up, and one of the big problems that you can get into is if you heat things up too much, the water that comes out of your metal refinery, assuming you're using water as your coolant, will boil within the pipes and break the pipes, right? So there is something to keep in mind there. A simpler solution might be to just have this output line go and dump into some sort of ice biome somewhere, right? So we would dig out, say, to here and just have our water dump out into here and warm up and melt down this ice biome. There are pros and cons associated with that as well. There are a lot of really interesting things that you can do as well with the metal refinery because you don't have to have water as your coolant. You can basically have any liquid as your coolant. Now, the temperature change of the coolant is, one, obviously going to depend upon what metal you are refining in your metal refinery. Again, steel is going to be the one that's dumping the most heat in, whereas gold is going to be the one that dumps the least heat in. There's also aluminum somewhere in there, which I forgot to mention, and I don't have the numbers for offhand. I assume aluminum is somewhere around where copper is. In any case, the temperature difference of the coolant coming in and the coolant coming out is going to depend upon how much heat you're dumping into it per operation, which depends upon what type of thing you're refining. But it also, of course, depends upon the coolant, because different coolants have different specific heat capacities. So if I were to run water through my metal refinery, right, and I was using steel as my my batch, my recipe, right? If I was producing steel with my metal refinery and I ran water in, the water that comes out is going to be about 56 degrees hotter than the water that came in. So if I send in water that's 44 degrees or higher, what's going to happen is it's going to boil and break by pipes on its way out. So you need to be careful about what you're using there. And if you use different coolants, these coolants will have different boiling temperatures, but they'll also have different specific heat capacities. And so if I were to, say, use crude oil as my coolant, crude oil has a specific heat capacity of 1.69. So if I did that same operation where I was producing steel with my metal refinery, instead of going up the 56 degrees that the water would go up, because it has a lower specific heat capacity, the crude oil is instead going to go up 138 degrees, right? And the lower the specific heat capacity of the coolant that you use, the higher this temperature increase is going to be. Now, this also allows you to create some really, really hot liquids. If you wanted to create super hot liquids, if you wanted to melt other things down, you could be using crazy coolants in your system. You could be using molten glass in your system. If you ran molten glass as your coolant through this system, if you ran, say, steel as your recipe in this metal refinery, the molten glass would come out 1,170 degrees hotter than it came in, right? So you can really pump up the heat of a lot of these things and use that for certain applications where you try and melt down other elements. It's also interesting, though, that the metal refinery itself does not have very good thermal communication with the area around it. That basically, it only the contents of this metal refinery only are in thermal communication with the air around the metal refinery and this tile right underneath it. So if you set up a metal refinery that is in a vacuum, right, and you have some sort of airlock for your duplicants to reach that area so that they don't bring in oxygen and other gases with them. If you have some sort of airlocked area where this is in a vacuum and you insulate this tile right here underneath the metal refinery, you can pump some really hot stuff through these pipes and not have to worry about the temperature getting out and escaping. So just to kind of illustrate some of the creative things that you can do with a metal refinery to produce your refined metals, one option is you dig your way down to somewhere, say, like right here, and you can go ahead and dig out some area like this. The magma will flow over here. Magma will basically go as far as 10 tiles. If we dug this out, say 11 tiles wide, this actually would not go all the way, I believe. Although this does have a little bit of extra pressure on top of it, so it might make it to this 11th tile. Let's see. Slowly making its way over there. But we're going to see a sort of gradient in how many kilograms we get in our magma here, right? And we can eventually get it to somewhere around over here. And then it'll probably stop. But in any case, we can dig out some area like that. And then what we can do is we can set up a pump. So let's go ahead and we can build ourselves a little pump right here. And the trick that we're going to use with this pump, and I've kind of gone over this in my my heat management, ways of producing extreme heat video. If we set up a pump like this, and I'll just use some insulation tile here, and let's clear out some more area up here. And we'll say tile right here, plumbing, liquid vent, make this out of anything. What we can do is we can trick this pump into running and pumping out this magma right here into the pipe by just putting a little bit of liquid on this tile right here. And what we'll do is we will then say plumbing, liquid filter. We'll set up a liquid filter, say right here, have some insulated liquid pipe, go up like this. And we'll use this liquid filter to filter out the little bit of liquid, say naphtha or crude oil or whatever that we leave right here. And we can have that continuously dump on here, allow this liquid pump to continue pumping, pump out this magma, and then take the filtered magma that we get out. So plumbing, insulated liquid pipe, let's say, igneous rock. We can take that line and use it to go ahead and feed a bunch of metal refineries, right? So if I dug out this area right here, let's say, that wasn't quite even. Let's also delete this little bit of magma right here. I could have some vacuumed out area right here where I set up my metal refineries. We'll say one here, one here, one here, right? And whoops, we can clear out this area, say right here. I'll probably have like a ladder going down, right? Probably a ceiling somewhere over here. I can put a bunch of my power buildings just right up here, right? Have a bunch of like coal generation sitting up here to supply these metal refineries with power. But I can basically just go ahead and say plumbing, liquid pipe. I can run this magma that I'm pumping out from the magma biome over to my metal refinery. It'll heat up that magma, dump it into the next one, have that dump into the next one. So that way I only need one pump to be able to supply all of these systems. And then just have this one dump out right here. Dig out these tiles right here. And set ourselves up a liquid vent. Something like this, right? And basically, because I have this entire system under vacuum, and let's kind of make sure it stays under vacuum by tiling off over here, because I have some gas that I've kind of released over here. But as long as I keep this area in vacuum, right, and pump a little bit of some non-magma liquid, just a tiny bit, right, like 10 kilograms basically, just enough to kind of wet this surface. I can have this pump run, pump out the magma, pump it into these metal refineries, and then just dump it right back out into the magma biome, right? And there's a lot of thermal mass in this system. I mean, each of these tiles has 1,840 kilograms. Magma has a specific heat capacity of 1. Each operation that we send this metal refinery through, if I'm running magma through the system, a batch of steel will increase the temperature by 234 degrees. A batch of iron will increase it by 134 degrees. A batch of gold will increase it by 26.4 degrees, right? We can kind of set these things up so that the risk, I guess, is that if all of these were running steel and we heated the system up a little bit too much, then we could potentially boil off our magma into rock gas, which would be pretty bad. But it wouldn't be hard to set up a system here with some sort of airlock, right? We can set up a liquid lock like we had up earlier, right? Get some crude oil right in here. We basically take a bottle emptier and empty out some crude oil into here, which is pretty easy to find around here, right? Get rid of these. Maybe I didn't put enough in. Either way, you can set up a liquid lock pretty easily. Have your duplicates go through here. You probably want them to be in Atmos suits as well. Yeah, I've allowed some carbon dioxide in, it looks like. In either case, you can vacuum out this room, set up these metal refineries, and these metal refineries will be able to process a lot of your refined metal, a lot of your steel operations for you, and basically just take all the heat and dump it out into this already hot area that you're going to not deal with anyways, right? So One of the ultimate ways of dealing with the heat coming from metal refineries is just to dump it somewhere that you don't care about. Maybe that's an ice biome that you are perfectly happy having it melt down. Maybe that's back into this magma biome. There are a lot of different options. You could be using that heat in a really productive way, either to generate steam and generate power for your base, or to melt down regolith into magma or do something crazy like that. A lot of cool stuff, a lot of cool tech. I have a video that shows a lot of the cool things you can do in terms of producing extreme heat and really pulling off really cool tricks in the game. I urge you to go and watch it. I'll probably link it in the outro here. But yeah, a lot of really interesting things you can do with metal refinery. The main trick is you need to have that water supply coming in and water supply going out, and some ultimate solution for, you know, how am I going to deal with the heat that generates. Dumping it into some area that you don't care about is a great solution. I highly encourage it. But absent that, you probably want to have set up some solution. Ice makers, steam turbines, right? Some heat management thing has to be set up. And we'll get to that sort of newbie-friendly, beginner-friendly heat management options early on. Interestingly, this lead melted? Okay. We'll get into some of those options later on. But for now, just know that it's going to produce a pretty good amount of heat running these metal refineries. Be aware of that. Be prepared for this coolant to be pretty hot, and dumping your coolant into either the magma biome, right, if you're using magma as your coolant, or dumping it into, say, the ice biome if you're using water as your coolant is a pretty solid idea for operating these things. So that's pretty much it for this episode. To summarize, a lot of great buildings that you get built out of refined metal. In particular, in the early game, you're going to want smart batteries and automation wire. In terms of obtaining that refined metal, you can melt down kilns, you can dig to the top of the map, you can dig to the bottom of the map, you can dig around the map and find volcanoes. You can also just use the rock granulator. You will lose half the metal that you put in with the rock granulator, but still pretty simple solution. Doesn't output that much heat, and your only cost is some metal that you probably have a pretty good amount of anyways. And also can renew in the future by taking trips to space. And then finally, the late game solution, or maybe even mid game solution, depending upon kind of how advanced you are, is the metal refinery. Keep in mind, 80% of the thermal energy necessary to heat up that metal to its melting point from a starting point of 40 degrees Celsius is going to be how much heat is dumped into that coolant. And that can be a lot of heat. Again, we're talking somewhere in the order of 100 million DTUs just for one batch of steel. For 100 kilograms of steel, that's 100 million, roughly speaking, DTUs, broadly ballpark estimate. So be ready for that, be prepared for that. Make sure you're not putting in coolant that is too warm, otherwise it'll boil in your outlet pipes and cause problems for you. Easiest solution is just to take that hot coolant and dump it out somewhere cold, or dump it, if you're kind of doing one of these more advanced systems, dump it just right back into wherever you're drawing your coolant from, some place that you don't care. And yeah, I think that's it for the video. I think this kind of covers everything. In the outro, I'll have links to some more relevant videos, and good luck and have fun.